Hi everyone, welcome to my talk Microservice Container Kubernetes Why here at the VMware Tanzu Up Close virtual event. We are always talking about new exciting technologies and which problems they solve at a higher level. But do you really know why there's a need for microservice architectures, DevOps, CI/CD, and modern technologies like Kubernetes or containers at all? I will take you on a journey about how software development processes have evolved over the last decades and how this is related to modern technologies. First of all, I will introduce you to the most common software development processes, and afterwards I will show what impact they have on software architecture, development, operations, and of course the technologies used. Feel free to ask questions via the Q&A functionality of Zoom. There are also a few of my colleagues in the session who can already answer some of the questions. Let's start with the most widely used traditional software development process, the waterfall process. The process is called waterfall because one process step is followed by the next in a strictly defined order, as you can see in the process diagram. The waterfall process is not designed to jump back to brief steps, for example, due to planning errors. Therefore, errors that are discovered after a process step are very expensive and often difficult to fix. Let's now get a better understanding of the individual steps. So, first of all, there is an idea or a business problem that should be solved with the software. And waterfall is plan driven. So in the plan phase, all the requirements are collected and specified in detail. And the requirements specification is then often used for tenders and serves as a contractual basis. After that, a sequential project plan is created to accommodate those requirements and executed step by step in the build phase, for example, up to a defined delivery stage. The release or pre-releases of the software are then made available to the client or the business department on a test environment for manual acceptance tests of these features. If those are successful for the release version, the software application is then handed over to the operations department in the form of a deployment artifact together with an operation manual. And in addition to the operations of the software application, the operators are also responsible for the support of it. After that, the contract is fulfilled and the software development team starts working on a new project or a new iteration of the software. With a waterfall process, one software iteration normally has the duration of 6 months to 12 months or longer, and with that the feedback loops are really long. On the one hand, this long process has a negative impact on the quality of the application, and on the other hand, it's often too late to respond to feedback. And another problem is that common project instead of a product mindset. As a result, feedback from end users and bugs discovered late in the process are often not implemented or fixed at all, or not until the next iteration. With Agile, instead of one long release cycle that has a duration between 6 to 12 months or longer, we have multiple smaller cycles or iterations with a duration of only a few weeks. And additionally, it is possible to jump back to a previous step if, for example, something cannot be implemented as planned. Agile is value-driven and defined by a set of values and principles that promote iterative delivery, flexibility, teamwork, and communication, as stated by the Agile Manifesto. The Agile Manifesto is a document that identifies 4 key values and 12 principles. The 4 key values are the things rarely change and we believe to be true. These are individuals and interactions over processes and tools, So valuing people more highly than processes or tools is easy to understand because it is the people who respond to business needs and drive the development process. If the process or the tool drive development, the team is less responsive to change and less likely to meet customer needs. Communication is an example of the difference between valuing individuals versus process. In the case of individuals, communication is fluid and happens when a need arises. In the case of process, communication is scheduled and requires specific content. The next value is working software over comprehensive documentation. With Waterfall, enormous amounts of time were spent on documenting the product for development, operations, and the handover to other development teams, like, for example, technical specifications and the operation manual. This can be a cause for long delays in development. HR values documentation, but it's more focused on the information that's really required. HR documents requirements as user stories, which are sufficient for a software developer to begin the task of building a new functionality. Customer collaboration over contract negotiation is the next value. So with a waterfall, the customer's requirements are often defined in great detail prior to any work starting. This meant that the customer was involved in the development process before the development began and after it was completed, but not during the process. And with HR, the goal is that customers are engaged and collaborate throughout the development process. And this decreases the risk to not meet the needs of the customer enormously. The last value is responding to change over following a plan. HR's view is that changes always improve a project and provide additional value, in contrast to traditional software development, which regarded changes as an effort. Principles are guided by values and things that help us achieve our values. The summary of the 12 principles defined by the HR Manifesto are early, iterative, and frequent releases of working software to get feedback fast and reduce risk. Flexibility, so welcome change. Empowered, collaborative, sustainable, co-located teams. And a spirit of continuous improvement. Practices are built on top of principles to solve specific problems. Pair programming, for example, improves code quality, and the direct feedback reduces the time required for code reviews. And it's also faster than two separate developers because you have that knowledge sharing and you're really reducing bugs. As you can see on the right, practices are only the tip of the iceberg, and without the values and principles in mind, they have minimal impact. We often see that this is not the case and that certain practices, such as, for example, Scrum, are used with all the defined meetings, all the roles, 2-week sprints, etc. But the values and principles are not lived within the organization. And as an example, because the product team is not empowered to make decisions, they are not able to change the product based on feedback without a management approval. As you can see in the diagram on the left, with a waterfall, the risk constantly builds up during those 6 to 12 months of an iteration due to the early and frequent release of the software and the received feedback. With HR, the risk is continuously minimized and minimal time is wasted if, for example, there is no user need for a functionality or there is a bug. Part of the VMware Tanzu portfolio is VMware Tanzu Labs. The goal of those experts is to enable our customers in a modern way of software development and software operations. And they have a 30-year track record of enabling software transformations for companies of all sizes. VMware Tanzu Labs uses extreme programming as its agile software development framework. Compared to Scrum, it defines 12 additional practices that are based on the agile values and principles. Examples are paired programming or test-driven development, where a test is written before the functionality in order to reach a high test coverage, but also other things like a good interface design or minimal code. Another practice are the 12 and not listed here is sustainable pace, which is an extremely important practice to ensure the quality of the software, especially compared to Scrum where iterations are named sprints. Our labs colleagues do not work more than 8 hours per day, and the software is also only released when there's something valuable to show. With a Scrum, after each sprint, a lot of pressure that leads to overtime and poor software quality is created with a committed software releases and so-called sprint reviews where stakeholders review the progress of the team. Even with the agile, a lot of things can be done wrong. It often happens that product or business model risks are ignored or assumptions are not sufficiently validated. Another example is that after the end of an iteration, there is not enough testing or now feedback gathered. And like with the waterfall, this leads to constantly increasing risk. The agile approach is inspired by startups, so it makes sense to take a look at the common reasons startups fail. And as you can see here, most of them are related to the product or the customer and not the expertise of the development team as often assumed. Lean was developed to address this. Lean is a methodology designed to reduce risk and reduce waste in the form of, for example, unnecessary written code through constant validated learning. One of the core components is the build, measure, learn feedback loop that is broken down into the following steps. Identify the biggest assumptions, risk, and value. Understand the problems actual customer face. Do prototype and usability testing. With the tools available today, there is often no need to write any line of code for this. And define and work towards a minimum viable product, where the goal is to implement the minimum scope with the maximum value in order to be able to validate the assumptions quickly and, of course, to be on the market quickly. Now let's have a look how a combination of Agile and Lean looks like. A continuous validated backlog of features that will be implemented next, reflecting the current product priorities. Small incremental releases for the fast feedback. Iterations instead of sprints, and releasing when there is something valuable. And thinly sliced stories that represent end-to-end functionality to add value. Because if you have one story for the front end, and one for the back end, and one for the database, you only add value as soon as all of them are implemented. This combination, for example, is good for people because it promotes sustainable pace and fosters collaboration. It's good for the product because the software is fast in the hand of the customers and focused on those. And it's good for the business because risk will be constantly reduced and it's possible to adapt to changes in the market, competition, and the technology. As I already mentioned earlier, VMware Tanzu Labs uses extreme programming as its agile software development framework with 12 defined practices in combination with Lean to reduce the risk of building the wrong thing through constant validated learning and user-centered design, where the focus is on designing the product based on the needs of the real users. Now let's have a look at the traditional software architecture, development, and operations. Here is the waterfall process again. In the next few slides, I will give you more information how the design, build, test, and release phases usually look like with a waterfall process. A typical result of the waterfall approach is a complex application with monolithic software architecture and a large code base. And often all components are very tightly coupled and the application has grown over years. And as the source code of the application grows and gets more complex, more errors occur and feature delivery slows down. But its much simpler deployment topology can avoid many of the pitfalls associated with distributed systems. This can result in much simpler developer workflows and monitoring, troubleshooting, and activities like end-to-end testing can be greatly simplified as well. Monoliths can also simplify code reuse within the monolith itself. If we want to reuse code within a distributed system, we need to decide whether we want to copy code, break out libraries, or push the shared functionality into a service. With a monolith, our choices are much simpler, and many people like the simplicity. On those large and complex applications, there are often many developers working together on the large code base. And this leads to low productivity since they get in each other's way, and it's difficult, especially for new team members, to understand all the code. As already mentioned, with Waterfall, there is often a project instead of a product mindset, where a project team is often only responsible for one iteration or version of the software and also only for the implementation and not the whole life cycle of the application. Another critical aspect is that often only documents such as the requirement specification or operation manual are used to communicate with a business department or operations. As a result, a lot of information, time, and feedback is lost or not used. And it's worth mentioning that in terms of the programming languages, not too much has changed. And frameworks such as, for example, Spring have also been around for 18 years. And finally, developers were often also responsible for the user experience and the user interface of the applications, which explains the often user unfriendly interfaces. Quality assurance or testing of the application, often in the form of so-called acceptance tests, is usually done manually by the business department. And due to the project mindset, anything that is not found here or is too complicated to fix will often not be fixed at all, and the customers have to deal with it. The release process is really like the illustration here. So the software application is handed over to the operations department in the form of a deployment artifact together with an operation manual. And the operators are responsible for the operations and the support of the software application. After that, the software is deployed on the servers or middleware, such as, for example, vSphere. And it's not unusual that the deployment and provisioning of, for example, the middleware is not fully automated, which is, of course, time-consuming and error-prone. But due to the long release cycles, however, it's not a big problem if the provisioning of the service and middleware takes several weeks or even months. Now let's have a look at the impact Agile has on software architecture, development, operations, and the technologies used. As a reminder, here is the modern Agile process with its multiple smaller cycles or iterations that have a duration of only a few weeks. The disadvantage of monolithic architecture for a complex application are addressed by a so-called microservice architecture with the agile values and principles in mind. And the complex application is implemented as more loosely coupled microservices so that software development teams can work in parallel, and the code base also smaller and easier to understand. This leads to higher productivity and fewer errors. The microservice architecture also brings technical advantages such as flexibility in the technologies used for the microservices and better scalability and reliability of the application. I just said that a microservice architecture solves problems of complex monolithic applications. The complex is important here because the microservices are distributed systems, which creates additional complexity in terms of operation and the synchronous or even asynchronous communication of the microservice over the network with, for example, REST. For the success of microservice, an agile and DevOps culture is also necessary because, as I just mentioned, the operation of such an application is complex and requires a lot of collaboration between the developers and the operators. I will explain DevOps in more detail in a moment. In summary, microservices architecture is the choice for a large and complex application and therefore almost always for the modernization of legacy applications. However, if you are, for example, starting with a new application, you usually start with a monolithic architecture where you can, of course, build modular code so that you can easily split it up into microservices later if necessary. With a microservice architecture, instead of working with a large team on a large code base, it is now possible to work with small teams on small code bases in parallel. The team should include all disciplines that are necessary for software development in order to promote communication. For example, from the business department, designers, developers, and people who are familiar with infrastructure. This is a so-called balanced team, which of course must also be empowered to make its own decisions regarding the product. In addition, a product over project mindset is very important so that one team is responsible for the full life cycle of the application and continuously improves the application and adds new features based on the user's feedback. An important factor for success is also a good build and test automation and coverage so that the software can be released frequently, a so-called continuous integration of changes to the source code to detect integration errors as quickly as possible. In the past, the IT usually supported only a few programming languages, frameworks, and technologies, for example, vSphere as a runtime for Java application with Oracle database. In order to benefit from the technical freedom of the individual microservice, more flexibility is necessary. Regarding the quality assurance, the importance of testing has increased and testing has been integrated into the core work of developers due to the automation required for frequent releases. Test-driven development is very helpful here for a high test coverage. Basic needs of applications with microservice architectures are the collaboration between developers and operations teams, so-called DevOps culture, the rapid automated release of deployment of the application through CI/CD and containers, the rapid provisioning of infrastructure with the help of containers and Kubernetes, and the basic monitoring because in distributed system it is difficult to find the cause of errors. DevOps is a collection of software development practices that brings software development and IT operations closer together with automation. It breaks down the barriers between dev and ops to shorten the time it takes to release high-quality software. The DevOps movement is aimed at removing silos and encouraging collaboration between development and operation, and also aligning the goals of the two areas. The first step in the direction is a self-service instead of IT tickets, so developers and operations can act independently. And vSphere or VCF with a Tanzu or VMware Tanzu Mission Control provides this out of the box. With the containers, we have a standardized way to package an application, its configurations and dependencies together into a single logical object. For microservices, containers provide, for example, the flexibility in deployment options versus a pre-installed middleware and a much faster startup times than VMs, which is important for their resilience. They also promote a higher utilization of several resources, and it's easy to move them around and to replicate them. Containers solve some problems, but they create new ones. So for example, how do I provision the hosts my container will run on? Or how can I scale my application? How can I add layers of high availability? Or how do I expose my application to the world? The solution is a container orchestration system like Kubernetes. Kubernetes is the de facto new infrastructure standard for modern applications. Now let's talk about CI/CD. The abbreviation CI stands for continuous integration, and the goal is to build and test the new source code to detect integration errors as quickly as possible. CD stands for continuous delivery or deployment and means the automation of the release process for frequent releases. The difference between continuous delivery and continuous deployment is that with continuous delivery you can do frequent production releases, but many choose not to do it, usually due to businesses preferring a slower rate of releases. And with continuous deployment, every change goes through the pipeline and automatically gets put into production. Here we see a typical CI/CD process for deploying an application to Kubernetes. In this case, with the products of the VMware Tanzu portfolio, which provide additional security, consistency, and observability. It all starts on the bottom left with an idea, which is then implemented as software. Part of the VMware Tanzu portfolio are the development framework Spring and CL2 for .NET. Newly written code is then integrated into version control software such as Git, and then automatically built and tested using solutions such as Jenkins, GitHub Actions, Tecton, or our Concourse to detect bugs as soon as possible. Since we want to release our modern application on Kubernetes, the next step is to build a container image that contains the runtime environment together with the application and push it to a container registry. Part of our portfolio is the Harbor registry. The VMware Tanzu build service does this automatically with the so-called build packs that are known from Cloud Foundry, and the containers are built for all common languages with the best practices in mind. And in case of CVEs in the middleware or the operating system, new containers where the patch components are automatically created. Together with, for example, databases or a message broker for which open source container images can be provided by our Tensor application catalog or Tensor data services, the container image of the application is then deployed to the Kubernetes cluster by a continuous delivery pipeline and can be monitored by an observability solution such as Tensor Observability by Wavefront. In addition to our own Kubernetes distribution, Tensor Kubernetes Grid, we also offer Tensor Mission Control, a solution for centralized management of Kubernetes clusters, and Tensor Service Mesh. In the following months, there will be a new product available that's currently in public beta called Cloud Native Runtimes for VMware Tanzu. Cloud Native Runtimes for VMware Tanzu is a set of capabilities that enables developers to leverage the power of Kubernetes for serverless use cases without first having to master the Kubernetes API. And it's based on the open source Knative project and can be used by itself or in concert with other Tanzu capabilities to quickly get modern cloud native applications with event-based architectures up and running on Kubernetes, regardless of developers' level of experience with the platform. Worth mentioning is also our VMware Tanzu application service that is based on Cloud Foundry and Platform as Service that enables higher developer productivity than container as a service, like for example with the Kubernetes. With a simple cf push command, an application is deployed in production, and with further simple commands, it is also possible to create services instances such as a database and make them available to the application via auto configuration. Tensor Application Service is not only the best platform for Spring Boot, it also supports, for example, .NET Core and Framework and all other popular programming languages and frameworks. The products of the VMware Tanzu portfolio can of course be licensed individually, but also in soft bundles. We have the Tensor Basic Edition to deploy our Kubernetes distribution, Tensor Kubernetes Grid on vSphere. With a Tensor Standard, you can additionally use Tensor Kubernetes Grid on the supported cloud providers such as AWS or Azure, with a centralized management of clusters via Tensor Mission Control. In Tensor Advanced, all the products that I showed you in the previous slides are included for typical DevSecOps supply chain. Here is a great summary of the previous slides. The result of the waterfall approach is often a complex application with a monolithic software architecture where a large team works on a large code base that is often non-modular. And compared to microservices, where a complex application is implemented a small loosely coupled microservice so that several smaller software development teams can work in parallel, and the code base is also smaller and thus easier to understand. With Waterfall, there is often a lack of collaboration between developers and operations, and in contrast, we have the DevOps culture, which is a basic need for fast release cycles and microservices. And finally, the manual testing and release compared to CI/CD, which enables fast release cycles. In summary, I come to the conclusion that without the shift to an agile and lean mindset and culture in an organization, things like Scrum, microservices, containers, or Kubernetes will change nothing. And for that, we have the VMware Tanzu Labs to enable you regarding an agile and lean mindset and culture on the modern applications and infrastructure side. Thank you very much for joining my session, and I hope you enjoyed it and learned something. and I will now spend some time on answering questions if there are any.